Euclid's Elements, Book 2, Proposition 3. If a straight line be cut at random, the rectangle contained by the whole and one of the segments is equal to the rectangle contained by the segments plus the square on the aforesaid segment. So we've got our straight line AB, and we cut it at random at C. And what we want to show is that the rectangle contained by the whole and one of the segments, I'm going to choose CB. So we go AB, CB rectangle is equal to the rectangle contained by the segments, so AC, CB, plus the square on the segment we chose for this rectangle, which would be CB. So that's what we're going to show. First thing we want to do is use proposition 46 from book 1. And we're going to construct a square on CB. We'll call this DE. So Prop 46 allowed us to construct square CE. Step 3, we are going to extend DE out. So this is parallel to AB. Extend DE out to F, and then we're going to drop, call this F. We're going to draw AF parallel to CD or BE. So proposition 31, AF is parallel to CD. Now, the figure AE is really the rectangle ABCB because BE is a side of the square CDEB, so CB and BE are equal. And our figure AD is the rectangle AC CD, but CD, being a side of this square here, is equal to CB. So we can write up, I'll just write this AD, figure AD, which is a rectangle, is really the rectangle ACCB. Step 5. And the square DB is, or the figure DB, which is a square, is the same as the square on CB. So DB, which is a square, equals the square on CB. Therefore, our rectangle ABCB is equal to the rectangle contained by the segments ACCB and the square on CB. QED.